Welcome back. This is the second half of the second lecture, and in this lecture we will discuss about the purine salvage pathway. So what happens in purine salvage pathway and what kind of disorders are associated with this pathway, we are going to discuss in this section. Let's move toward the board, and you can see that inosine monophosphate. From the de novo synthesis, the main compound that has formed was inosine monophosphate. I haven't removed the certain section from the previous lecture, that is inosine monophosphate, from which you can derive both guanosine monophosphate, and I removed the adenosine monophosphate portion. So what happens, you can say that inosine monophosphate forms guanosine monophosphate and also form adenosine monophosphate. These are the nucleotides, purine nucleotides. Let me write here nucleotides, right? So IMP, from where did we get it? The IMP we actually got from de novo synthesis. Ribose 5-phosphate gives us by the activity of PRPP synthetase enzyme. PRPP synthetase enzyme. So you remember from the previous lecture that PRPP synthetase on acting ribose 5-phosphate going on through the certain levels gives us what? Inosine monophosphate. So these are the nucleotides that derive from the inosine monophosphate, and guanosine monophosphate and adenosine monophosphate derived from the inosine monophosphate. Now you can see that guanosine monophosphate, and this is guanosine. I told you that removing one phosphate from the nucleotide will convert it into nucleoside. So these are the nucleosides. Now you can see that this section, nucleosides, the nucleoside of nucleotide guanosine monophosphate is guanosine, and here from inosine, if I remove the phosphate group, this will become inosine, right? Inosine. And this AMP, let me write here, this is adenosine. These are the nucleosides. What happens that I can say that IMP degrades into inosine by just removing a phosphate. Similarly, GMP degraded to guanosine just by removing a phosphate. Similarly, IMP into adenosine by just removing a phosphate. We make the nucleosides from the nucleotides. If I remove the ribose portion, let's say from here a phosphate is removed, this is inosine, and if I remove the whole ribose portion from here, it will become hypoxanthine, right? This will become hypoxanthine. Similarly, if I remove the whole portion from ribose 5-phosphate from the guanosine monophosphate, it will become guanine, just a free base, right? Now see, this is degraded by removing the whole ribose portion into the hypoxanthine. Now just keep in mind what happens actually. For hypoxanthine and guanine, these two free bases can be converted into their monophosphates, by having a single enzyme. The one enzyme is required for hypoxanthine to get converted into inosine monophosphate, and guanine to get converted into guanosine monophosphate. Only one enzyme is required, that is known as hypoxanthine guanosine phosphoribosyl transferase. Keep it in mind. This is HGPRT is hypoxanthine guanosine phosphoribosyl transferase, that is required for guanine to convert into guanosine monophosphate and for hypoxanthine to get converted into inosine monophosphate. Now, the hypoxanthine is further degraded into xanthine. Let me use a blue marker here. Hypoxanthine converts into xanthine. Now, if guanine is not converting into guanosine monophosphate, it will also get converted into xanthine, right? Now, from xanthine, further degradation will occur into uric acid. The two enzymes are required here to get converted from hypoxanthine to xanthine, and from xanthine to uric acid, that is xanthine oxidase. Xanthine oxidase. Keep it in a mind. Xanthine oxidase are the two enzymes that are required for hypoxanthine to degrade into xanthine, and from xanthine to uric acid, and uric acid further degraded into allantoin. Right? Now, adenine is a free base that will get converted into adenosine monophosphate. Similarly, let me tell you, as for guanine to get converted into guanosine monophosphate, HGPRT is required, and that is the same enzyme that is required for hypoxanthine to get converted here. Adenine required APRT. APRT. Adenine phosphoribosyl transferase. Now, these enzymes are very important. There are certain disorders are associated with these enzymes. How we will go through very soon here. Now adenosine can also be converted into inosine, right, by one enzyme that is very important enzyme, that is adenine deaminase enzyme. Adenine deaminase enzyme. Now let's move what actually happens. You will get a concept that if we have the free bases here, hypoxanthine, guanine and adenine, these free bases can be saved by the salvage pathway in a way that hypoxanthine will get converted into inosine monophosphate and guanine will get converted into guanosine monophosphate by using this enzyme. This is HGPRT, hypoxanthine guanine phosphoribosyl transferase, and adenine will get converted into AMP by APRT, adenine phosphoribosyl transferase. So this cycle continues until and unless there got some problems. What kind of problem are there? Let's discuss the first problem. So what actually happens? This ADA, adenosine deaminase enzyme, can be inhibited in certain diseases. What diseases? There is a disease named as severe combined immunodeficiency. This is a syndrome that is X-linked recessive trait syndrome. In this syndrome, ADA enzyme is not there. So if there is no ADA, means that adenosine will not convert into inosine, inosine will not convert into hypoxanthine, and it will not saved in the form of IMP to further convert it into AMP, right? So what happens in SCID, and what is this enzyme is required for? If this is not there, ADA is not there, there will be no salvage of adenosine, and this will result in the decrease of DNA precursors, and as a result of this we got one problem, that is decreased lymphocytes. Decreased lymphocytes. Decreased lymphocytes means low immunity, because there are no lymphocytes, B and T cells. So the immunity will be decreased. So this is the problem, that is SCID, severe combined immunodeficiency. ADA is inhibited, there is no EDA actually. And in some diseases like cancer, when we gave some chemotherapeutic drugs like CTDs, these chemotherapeutic drugs inhibit adenosine deaminase. So when this ADA will be inhibited, the same process will happen, low immunity, right? So anti-cancer drugs will result in low immunity. Okay, now let's move toward the HGPRT. If this enzyme is inhibited or less due to certain reason, any reason, what will happen? GMP will not convert into GMP, and hypoxanthine will not get converted into IMP, right? This happens into also an X-linked recessive trait, a disorder named as Leach-Nyhan syndrome. So what happens? This enzyme is deficient, HGPRT. That will not convert, that will not save these DNA precursors. So what will happen if this enzyme is not there, guanine will not be there, and hypoxanthine will not be converted into IMP. So as a result, what kind of disabilities and what kind of problems will get? You can memorize it by using the same name, HGPRT. Now H will gives us a problem, that is hyperuricemia. Hyperuricemia. How? You can see when hypoxanthine will not convert into IMP due to the deficiency of this enzyme, this will get converted into xanthine and this will get converted into uric acid, and there will be a serum increment of uric acid. Serum increment of uric acid. The means that the uric acid level will increase in your serum level. The normal level is like 3 to 7 milligram per deciliter. This is the normal value. If it exceeds from this value, the problem that will be come over is hyperuricemia. So this is the hyperuricemia, you'll get the deficiency of this. The second problem is gout. How? Because when there is more uric acid, it will accumulate into the soft tissues, into your joint, and will give you a disorder, that is gout. The third thing is pissed off behavior. Pissed off behavior means there is aggression in your behavior, and sometimes there is self-mutilation, like the person who's having this disorder will start eating his or her lips and also fingers. This is self-mutilation. So you can memorize it by pissed off behavior. Pissed off behavior. Right? What's going to happen in the pissed off behavior? That is self-mutilation and aggression. Now, the fourth thing is the lab finding, the laboratory finding, that is red-orange crystals. Red-orange crystals. This is a lab finding. You can find some red and orange crystals in the urine. And the fifth thing that is going to happen there is tensed muscle. Tensed muscle. That is dystonia. Dystonia. So this all will happen due to the deficiency of HGPRT, and this happens in a disorder that is known as Lesch-Nyhan syndrome. Lesch-Nyhan syndrome. All right. Now let's move toward other side, that is xanthine oxidase and xanthine oxidase. These can be inhibited, these xanthine oxidase can be inhibited by two drugs, that is febuxostate and allopurinol. These two drugs inhibit this xanthine oxidase that will help in the less conversion of uric acid. So you can say that this Lesch-Nyhan syndrome can be treated by using these two drugs, because if there is more uric acid level, you can control it by giving these two drugs, right? They will inhibit the xanthine oxidase and they will not get converted into uric acid. There will be no serum high level of uric acid. There will be no accumulation in the soft tissues and all that, and you won't feel all these symptoms in Lesch-Nyhan syndrome. So you can treat Lesch-Nyhan syndrome by giving these febuxostate and allopurinol. So that's all. That's the main purine salvage pathway. You can save from their bases, free bases, to the main components, and from the main components you can derive the main nucleotides. So these are the process. So from where are actually these are coming? You know that these are actually coming from nucleic acids, DNA, nucleic acid. right? This is also coming from nucleic acid, right? So that's all for today. And for the next, we are going to discuss about the pyrimidine synthesis. Thank you so much.